Hi students, welcome back. Today we're going to do 13.3, which is nonlinear systems of equations. It might seem a little overwhelming at first, but just remember we've done systems of equations before and it's all the same process. The difference is that instead of using straight lines, we're doing all these cool new equations that we just learned in 13.1 and 13.2. And always remember, it is really, really helpful to look at the graph to get an idea of where the solutions are going to be while you're actually doing the algebra. So let's take a look. All right, 13.3, nonlinear systems of equations. Let's review the systems of equations that we've done before. So a solution to a system of equations, if we just have two equations in two variables, that solution is going to be an ordered pair. Okay, it's just like the solution to an equation is an ordered pair. The solution to a system is also going to be an ordered pair. It's the ordered pair that makes both equations true. All right, so the graph of an equation is all the points that make that equation true. So the solution to two equations is going to be all the points that make both those equations true. That's where those two graphs intersect. Okay, it's all the points where those two graphs intersect. All right, and each point is described as an XY pair. So XY pairs are what our solutions are going to look like here. We've done this for the linear equations in two variables, and we also did it for linear equations in three variables. Okay. So there's an example here. Y equals x plus 2 is one equation, and you can see its graph there in orange, right? That's y equals x plus 2. The other equation is y equals negative 4x minus 3, and you can see its graph there in green, right? Visually, you see where those two graphs intersect at negative 1, 1. That's the solution to this system of equations, right? Because x being negative 1 and y being 1 solves both of those equations, and we can see that in the graph. Okay, so remind yourself of that. We've done that before. I know you guys are pretty good at this. Okay. So another reminder, there's two ways to solve these systems of equations. You can use substitution and we can use elimination, or you can use a combination of the two. Substitution is where we solve one equation for a variable, meaning getting that variable by itself on one side and plug it in or substitute it into the other equation to give ourselves one equation in one variable. Okay. Elimination is where we kind of carefully manipulate our equations so that we can add the two equations together and cancel out one of our variables, again, to get one equation in one variable. So we can use either of those methods to get rid of a variable, and then we've just got one variable, and we can solve that equation to get a numerical value for that variable. Once we do that, we plug that numerical value back into either equation to figure out the value that pairs with it, and that's our ordered pair that is our solution. So in our example, let's use substitution. I chose substitution here because both of these equations are already solved for y. So the first step is already taken care of for us if we use substitution. Okay, so since they're both solved for y, I'm going to take the y that equals x plus 2 in the first equation and replace the y in the second equation with x plus 2. Okay, so now we know since y and y are the same, I can use x plus 2 and y interchangeably. So I replace the y in the second equation with the x plus 2 from the first equation. Okay, now I have one equation and one variable. This x plus 2, here we go. This x plus 2 equals negative 4x minus 3. We know that that's true because y is equal to y. All right, so we use our substitution, And when we do that, we solve this this equation we've created for x, and we get that x is equal to -1. So if you take that first equation, solve it for x, you'll get that x is equal to -1. Then we plug that x is equal to -1 into one of our equations. I plugged it into this first one because this is the easier equation. So I plugged x is equal to -1 into that first equation. Right here, x is equal to -1, and solved that for y, and I got that y equals -1. So that means that when x is -1, y is -1, solves both of these equations. And when you look at the graph, you see x is -1, y is -1. That is a solution to both of the equations. You can see that graphically. You can also go over to our equations, and you could plug in x is -1, y is +1. X is -1, y is +1, and see that that's a solution to both of the equations. So it's a solution to the system, right? So that's what we've done before. We've used substitution and elimination. These are linear equations, meaning their graphs are straight lines. We can take a look at some equations that are not linear, and that's what we're going to start doing in this section. So here, substitution in 13.3 is really going to be your best friend. Substitution is usually the easiest way to go. Unless all your terms are squared, then sometimes elimination is easier. All right. So here we've got x squared minus 4y equals 4, and x plus y equals -1. So you can reorganize these terms, and graph these two equations. In fact, it's a really good idea to do that. One, because you should know how to graph both of these equations, and two, because it'll help you to know that you haven't made any mistakes as you're working through the problem. So that guy in orange is a parabola, and I've graphed it in orange, and then the equation in green is a straight line. So I've graphed that in green. And I can see already from the graph where these equations intersect, and they happen to intersect at more than one place, okay? So I can see from the graph there's probably going to be two solutions here. All right, now this one's nice. It's pretty clear where they're intersecting, but sometimes you can't tell where they intersect, and so you're going to have to use algebra to solve, okay? The graph is not enough. You need to use algebra to find these solutions and not just guess from the graph. All right. So using substitution, we're going to solve one equation for a variable. We could really, I think the second equation is really easy to solve for x or for y. So you could solve for y if you want. In fact, I recommend you try reworking this, but instead of solving the second equation for x, solve it for y, and then go through the whole process that way. Okay. So we're going to solve for x, and we get that x equals -y minus 1. I'm going to plug that in to the other equation. So I know that x is -y minus 1 based on the second equation. Now, since x is -y minus 1, I'm going to replace the x in my first equation with -y minus 1. So I take my first equation, and where it used to have an x, I put the -y minus 1. That's the substitution step. Okay. Now I have one equation and one variable, and I can solve for this variable, right? Multiply that out, do a little reorganizing. I see that I have a quadratic equation here, so I'm going to factor it, and that tells me that y is equal to 3 and y is equal to -1. So I have two values for y. Now that jives with the graph that I've created, because we see in our graph that I should have two values because I'm going to have 2 points, because there's two places where these intersect. Okay. So now in substitution, I know that y is 3. So I'm going to plug y equals 3 back into one of my equations and figure out the x value that pairs with y equals 3. And I know that y equals -1, so I'm going to plug y equals -1 back into one of my equations and find the x value that pairs with y equals -1. So the x value that pairs with y equals 3 from this equation down here is going to be -4. So I know that one of my solutions is x is -4, y is 3. And the x value that pairs with y is -1 is going to be 0, so that I know the other solution is 0, -1. okay? And when I look at my graph, I can see this is -4, 3, one of my solutions, and this is 0, -1, another one of my solutions. I can also take these values, let's do the 0, -1, and plug them up into here. If x is 0 and y is -1, that indeed does equal -1. If x is 0 and y is -1, that indeed does equal 4. Okay, so these are both solutions to both these equations. And so this set of ordered pairs is the solution to this system of equations. All right. When you enter this in my math lab, you're going to want to enter this solution, the parentheses, -4, 3 parentheses, and then you're going to put a comma between them, and then the next solution. Okay, so there's going to be a lot of commas. Be careful how you format your answers. All right. Go ahead and pause the video and work through what we just did to make sure you understand it. Okay, here's example 2, and here I'm going to use elimination. Substitution works really well in this section. The only time substitution doesn't work great is if all your variables are squared. So if all 4 of our variables are squared, it's just harder to solve for any one of them. We have to square root at some point. So if all 4 of your variables are squared, then elimination is a good route to take. So remember, in elimination, we're going to modify one equation, multiply it by something, so that we can add the 2 equations together and eliminate a variable. Looking here, I have 2 options. I can multiply one of my equations by a -1 to eliminate x, or I could multiply my second equation by a +4 to eliminate y. I'm going to choose to eliminate x. I suggest that after we work through this, you rework this problem, but multiply the green equation by 4 and try to eliminate y and see if you come up with the same answers. Okay, so we're going to eliminate x. So to do that, I'm going to multiply my green equation by -1 on both sides. In doing so, when I add the 2 equations together, x will cancel out. All right, so the x is added together, add to 0. The y's add to 5y squared, and the right-hand side adds to 15. Now I've eliminated the x, so I can solve this new equation for y. When I solve it for y, I end up with y equals the square root of, or negative square root of 3 and positive square root of 3. Take a second to remind yourself why there are 2 answers here. If y squared equals 3, then y is the square root of 3, because it's the thing that's squared will give you 3, but it could also be the negative square root of 3. Notice that negative is outside the square root, so we don't have complex numbers here. We don't have imaginary numbers. It's just that y could be positive or negative. When you square it, it gives you the +3. So we've got 2 values for y. Okay, and here's where it's nice to have this graph. So let's take a second and look at the graph. Our first equation in orange is an ellipse because we have 2 terms, or we have an x and a y, they're both being squared and they're being added, but the coefficients are different, so it's an ellipse. So that's why the orange one is the ellipse. The green one, we have the x and y are both being squared, but they're being subtracted, so it's the hyperbola, okay? So we can see from the graph that we actually intersect 4 times, okay? So there's gonna be 4 solutions to this system of equations, okay? And you can take your time and graph these first before you work towards solving them, or you can wait until after you solve them and graph them to see if your answers make sense, okay? All right, so we've got y equals negative square root of 3 and y equals the positive square root of 3. So for each of those values of y, we're going to plug them into one of our equations, and we're going to solve for the corresponding value or values of x. So I use my second equation because, again, I just find this one easier. They're both actually equally easy to use. I used my second equation, and I plugged in y being the square root of 3. So when I plug in y is square root of 3 into my second equation, I end up getting that x is plus or minus 2. Right? Square root of 3 squared is 3. I'm subtracting that, so I'll add it to both sides. And I get plus, x is plus or minus 2. Okay. Sorry, I might have misspoken there. We square the square root of 3 to get 3. We'll add 3 to both sides. We get x squared equals 4. But when we square root both sides to get x, we get that x could be plus or minus 2. So that's how we get the 2. We add 3 to both sides so we get x squared equals 4. When we square root them both, we get x is plus or minus 2. Okay? So when y is the positive square root of 3, x can be plus or minus 2. That's going to give us 2 solutions. That's going to give us negative 2 square root of 3 and positive 2 square root of 3. We still have to go through the process for when x is the negative square root of 3. Well, when x is the negative square root of 3 and we square it, we still get 3. So when x is the negative square root of 3, when y is the negative square root of 3, x is plus or minus 2. So that gives us 2 more solutions. So in total, we end up with 4 solutions here. All right, when y is the square root of 3, we get the plus or minus 2 for x. When y is the negative square root of 3, we get the plus or minus 2 for x. So that gives us our 4 solutions there. And those are the 4 points that we see here. Notice they're all at x is 2 or x is minus 2. And the square root of 3 is almost 2. It's like 1.7, something like that. Okay. We get a positive 1.7, negative 1.7, negative 2, positive 2. All right. Pause this, look through what we just did, and then try through and solve it using elimination, but try eliminating a different variable. Okay. That is 13.3. Take a look at the examples in the textbook and email me if you have any questions.